My project is called Biofuel, a home run for the environment. There is an energy crisis in California. Since sports are very popular and sports stadiums require a lot of energy, I wanted to see if it was possible to use biowaste that was produced during the sporting event and to turn it into ethanol to provide electricity. I found that it is possible to do this through the use of enzymes and yeast. I hypothesized that the ethanol produced from the stadium would provide 170% of the required energy, or around 21,000 kilowatt-hours of electricity. I used 4 types of materials. The first was switchgrass. I used it because many experiments used it, and I also used it as a control. Secondly, I used wildgrass. Wildgrass has similar properties to switchgrass. The main grass I focused on in my experiment was Bermuda grass, because it's a common long grass and that's what would be used at a sports stadium. Lastly, I used sugar to check the effectiveness of the enzymes during hydrolysis. As a result, everything produced ethanol, but not as much as I expected. Sugar produced 0.279 milliliters per gram of ethanol. Switchgrass produced 0.275 milliliters per gram of ethanol. Wildgrass produced 0.013 milliliters per gram of ethanol as the least, and Bermuda grass, the focus of the experiment, produced 0.050 milliliters per gram of ethanol. In conclusion, the expected ethanol production was 66 milliliters for the 400 grams used, which would result in producing 170% of the electricity output for the stadium. But I only received 20 milliliters for the 400 grams of Bermuda grass, or 69% of the electricity consumption during a sporting event. The difference between these numbers was the fact that Bermuda grass was only 30% as effective as switchgrass at producing ethanol. I hope you enjoyed this presentation, and thank you for listening.